Have you ever wondered why a pendulum swings back and forth at a constant rate? Well, the answer lies in the fascinating world of oscillatory motion. Oscillatory motion is the repeated back and forth movement of an object around a fixed point. Think of a child on a swing, going up and down. Now, let's dive a little deeper into simple harmonic motion, or SHM. This is a special type of oscillatory motion where the force that pulls the object back to its resting place increases as you move it further away. Imagine stretching a spring. The pull you feel is stronger the further you stretch it. Some characteristics of simple harmonic motion include a fixed frequency, meaning it repeats at a constant rate, regardless of how far you initially move the object. It's also a periodic motion with a constant time taken for one complete cycle. The displacement of the object can even be described by a sinusoidal equation. But what happens when an object oscillates on its own? That's called free oscillation, like a pendulum swinging after you push it. However, because of things like friction and air resistance, the swings gradually get smaller and smaller until they stop. On the other hand, forced oscillation occurs when an external force keeps the object moving, like pushing a swing at regular intervals. The frequency of this motion depends on the force you apply, not necessarily the object's natural frequency. Then comes resonance, a phenomenon that happens when the frequency of your force matches the natural frequency of the object. The result is a large increase in the amplitude of the oscillations. Think of a swing reaching its highest point when pushed at just the right moment. Lastly, damped harmonic motion, a combination of simple harmonic motion and energy loss. This is where the back and forth motion slowly dies down and eventually stops, like a swinging door coming to rest. Examples of these concepts are all around us. A mass on a spring is a classic example of simple harmonic motion. A swinging pendulum under small angles also shows this motion but becomes damped due to air resistance. The vibration of a plucked guitar string is also simple harmonic motion at its natural frequency. Tuning forks can identify specific frequencies by resonating with other objects. Even the shock absorbers in your car dampen oscillations to improve your ride comfort. Understanding these concepts is crucial in various fields of physics, like waves, sound, and electricity. So next time you see a pendulum swing or a guitar string vibrate, you'll know exactly what's happening. Physics is truly amazing, isn't it? Have you ever wondered why a pendulum swings back and forth at a constant rate? Well, the answer lies in the fascinating world of oscillatory motion. Oscillatory motion is the repeated back and forth movement of an object around a fixed point. Think of a